Good morning. Just solve this question for maximum clock frequency. We need to calculate maximum clock frequency. Is this synchronous or asynchronous? Both. It is both synchronous as well as asynchronous. Right? So this part is asynchronous. Then if I consider this is a block, simple thing. If this is a block, this block and this flip-flop are synchronous. Point should be understood. Simple thing is which was given in previous gate exam. So this is a block. This is a block. Right? So this block internally asynchronous. And this block and this flip-flop are synchronous. There I can use a synchronous frequency formula. Then from the clock edge occurrence, how much time it takes to get stable outputs here? See, I need AND gate inputs which are stable from the clock edge occurrence. From the clock edge occurrence, to get stable outputs of this block, which is nothing but Q0 and Q1. These two will be ready in how much time? 2 flip-flop delays. Observe correctly, 2 flip-flop delays. Yes, from the clock edge occurrence it is changing. Again from the clock edge occurrence it is changing. That means it is taking 2 flip-flop delays are 2 delta, which is 2 delta. So it will be ready. These two will be ready in 2 flip-flop delays. It's not 1 flip-flop delay. So here from the clock edge occurrence, flip-flop delay, AND gate delay, and setup time. So finally, T minimum is equals to get ready here, it is a 2 TCK to Q plus combination block delay. How much is that? T AND gate delay plus T setup. How much is that? 2 into 100 picoseconds plus AND gate delay is 100 picoseconds. The setup time is also 100 picoseconds. It is the 400 picoseconds. Then F maximum is equals to 1 by 400 picosecond is the 2.5 gigahertz. 2.5 gigahertz. Anyone has any doubts? You can raise the hands on this, or you can type in the chat box. Very good. Some of you have answered very good. Excellent. Right? So people are in right way in analyzing sequential circuits. Analyzing sequential circuits. Right. Yes, I do. So this block internally asynchronous. Am I right? This block internally asynchronous. To stabilize these two flip-flops outputs, it takes two flip-flop delays because it is asynchronous. Rippling clock. So delta, then delta, or flip-flop delay, again flip-flop delay. That's what already we have discussed while drawing that waveform. So this is changing after a flip-flop delay, then this is changing after a flip-flop delay. That means from the clock edge occurrence, to stabilize these two outputs, it is taking two flip-flop delays. Then AND gate delay, then setup time of the flip-flop. Why? This is internally asynchronous. Here, while analyzing this block, we are looking for how much time it takes to stabilize here. Once we are able to calculate time required to stabilize here, what is the remaining part? This block and this block are synchronous now. Synchronous formula already we know that. So from the clock edge occurrence, how much time it takes to stabilize the outputs here, then AND gate delay, then setup time of this flip-flop. Assuming this is one flip-flop or one block, the block delay is how much now? Two flip-flop delays from the clock edge occurrence. Then AND gate delay, then setup time. So that's it. So this block delay from the clock edge occurrence is two flip-flop delays. From the clock edge occurrence, two flip-flop delays. That is flip-flop delay. Why? These two are asynchronous. Now, once it is stabilizing here, then this block and this block are synchronously clocked, right? This block and this flip-flop are synchronously clocked. Then again, same formula. So instead of one flip-flop delay to stabilize here outputs of AND gate, it is taking two flip-flop delays from the clock edge occurrence. Two flip-flop delays for this block, AND gate delay, and setup time of this flip-flop. That's what we have used. So finally, it is becoming 2.5 gigahertz. What is that, Manisha? What do you want to say? No, it is not like that, Manisha, because AND gate, both the inputs must be ready, right? AND gate output is driving this flip-flop input means AND gate, both the inputs must be ready. This is ready in one flip-flop, but this also should be ready. This also should be ready for that. Again, flip-flop delay. Again, flip-flop delay.
Sir, good morning.
Yes,
sir, here we have given the like for asynchronous clock, for asynchronous flip-flop, we have to give the Q naught as the clock for this asynchronous flip-flop, sir.
Yes, yes.
Then we can take the synchronous flip-flop. The first flip-flop is there, na, sir.
Yes.
That time delay, if we give as input to this asynchronous flip-flop, then it will be same, na, sir.
Yes, it will be same, but are we getting that Q1? If there are any changes, Q1 is ready.
Sir, like
Both, for example, both the inputs required 1-1.
Yes, sir.
So when you are observing this Q1, Q0, both the inputs are 1-1. Is it ready in one flip-flop delay?
Sir, I'm not saying like that, sir. Like if we take the first flip-flop delay like T equals to something.
See, I'm drawing the waveforms. You will understand more. So to stabilize AND gate output, we need stable inputs of AND gate, right? Yes or no?
Yes, sir.
This is clock. So what about Q naught? Is changing like this. Am I right?
Yes, sir.
What about Q1? Is changing like this. Because of this 1-1, AND gate inputs is becoming 1-1. Am I right?
Yes, sir.
So let me say that AND gate output Y is becoming 1 after 100 picoseconds, right? Then that will be captured by last flip flop at this clock edge occurrence, right?
Yes, sir.
So this is one flip flop delay, this is another flip flop delay, this is what? AND gate delay. And then that one should be ready setup time before clock edge occurrence. Now, are you able to catch?
Yes, sir.
Right? That's what we need to do. Right?
Thank you, sir.
Right. Not required. Not required. Strobe time is not required. These are ready earlier, not a problem. If you are expecting before this clock edge occurrence, how much time? No, not required. Not required to consider strobe time. Shubham. For both, not required. Anyway, those must be ready before this point itself, because after that we have AND gate delay, after that we have setup time of the flip flop. So if this also asynchronously clocked, there would have taken that strobe time. So here I need a time required to stabilize these two outputs. That's it. Am I checking at next clock at the occurrence? All these are ready? No. So what is that here expecting here? These two must be ready. That's it. Anyway, that will be before clock at the occurrence only. Shubham, please wait. I'll talk to you later. Right. So not required. Not required. It is not required whole time. Pawan Kumar. Is it after clock at the occurrence? Are we considering any time after clock at the occurrence? No. Pawan Kumar. Rumuluri Pawan Kumar. Yeah. Oh, yes. I understood your question now. Yes, correct. If you are calculating, what is it here? Whole time also, what is it here? Two flip flop delays plus AND gate delays must be greater than or equals to whole requirement of this flip flop. Yes. From the clock edge occurrence, two flip flop delays plus AND gate delay is the time required to reach from here to here. Yes, correct. Pawan Kumar, 100%. Yes. Very good. Right. This is a way people have been asking. It's already given in gate exam. It's not a new question. It is already given in a gate exam. See, when you don't know how to analyze a minimum clock period of synchronous, minimum clock period of asynchronous, it is not possible to analyze these type of questions. So this I've been discussing for many years, but recently we have been observing very good questions based on this. So follow correctly, understand correctly. Right. Now, there is a part remaining in sequential is FSM. What is this FSM? Let us see. FSM, finite state machine. What is finite state machine? Already we have designed a system which is going through a predefined sequence of states. That is also a system because it is generating expected output. If I use that outputs of the flip-flops to generate an output, yes, it is ready. So that is also giving expected output for some duration or for some inputs, for some sequence. We have seen how to generate output. So if you remembered, so a sequential circuit like this. What is this? We have analyzed this circuit already. When do we get output z equals to 1? When do we get output z equals to 1? When x is changing from 0 to 1. That means on serial input data, it is observing whenever it is getting 0 to 1, there it is resulting output is 1. Yes, whenever x is changing from 0 to 1, there z becomes 1. So this system is functioning as expected. What is it here? The functionality is it has to detect a 0 to 1 in serial input data. How many times we are getting 0 to 1? Those many times z will be 1. That is also a system. Yes, it is designed for checking 0 to 1 on serial input data. 0 to 1 on serial input data. Yes, it is a system which is checking for a 0 to 1 sequence in serial input data. So this system is used to check 0 to 1 on serial input data. I can design another one. Simple thing. The same thing. This we can say like this. You can analyze this will be 1 to 0. This system will be 1 to 0. To get z equals to 1, previously it must be given 1 and now it must be giving 0. 0 complement is 1, 1 is 1. So 1, 1, z becomes 1. Z becomes 1. Right, to understand correctly. What is it here? First it must be given 1, next it must be giving a 0. Then only z becomes 1. So this is detecting 1 to 0. This was the question. This was the question in ISRO exam. Right? The question is also very different. What is it here is x is changing from 0 to 1. That means there is a positive edge on x. X is changing from 1 to 0. Then it is a negative edge defining circuit. The entire circuit can be mentioned as a negative edge defining circuit because wherever x is changing from 1 to 0, there z becomes 1. That means the entire circuit we can name it as a negative edge defining circuit. See, level of questions we have been getting. The options are different. Positive edge defining circuit, negative edge defining circuit, mod 2 counter, mod 4 counter. So it is now z becomes 1 when negative edge is observed on x. Whenever x is changing from 1 to 0, then it is a negative edge only, right? When x is changing from 0 to 1, there if it is resulting z equals to 1, that is a positive edge defining circuit. Whatever the circuit we have analyzed earlier is a positive edge defining circuit. This is a negative edge defining circuit. Negative edge defining circuit. So these are systems designed for a specific function. These are very simple circuits. But to understand what is exactly FSM is a finite state machine. To meet expected functionality, you need to decide number of states it is going through. And after deciding number of states, what is the next thing? Minimum number of flip-flops required to design the system. Then we are designing the system using synchronous sequential circuit method. Once again, what is it here? By observing how many states a system is experiencing. How many states a system is experiencing. Once you are deciding that, we can decide how many minimum number of flip-flops required to design the system. So once you are deciding number of states required to design the system, we can decide a minimum number of flip-flops required to design the system. So I take always a general example. how to observe number of states. First, how to understand a system functionality. I take a general example, which is ATM machine. So, ATM machine has to respond to your inputs correctly. What are the inputs we are giving? So, inserting the card, entering the information, everything, it has to accept. Then, to perform expected functionality, you need to give inputs correctly. If it is not correct, what it has to do? If it is correct, what it has to do? All this already you need to take a decision, because you are the designer. System has been observing what inputs user has been giving, right? User has been mentioning the inputs, so your system must respond correctly without fail. What do you mean by this? For example, so let me take a ATM machine. So when you are entering into the ATM room, so system is in initial condition. So remember this point, every system has its own initial state. When you switch on your mobile, it is in initial state. When you switch on any electronic system, it will be in initial state. That is initial state, nothing is given. And your ATM machine also is in initial state. Now, what is the first step we do after entering into ATM room? Inserting the card. Inserting the card. What is the possibilities you are expecting after inserting the card? Please involve in this to understand. Right? So what is it here? When you are entering into ATM room, what is the first step we do? Inserting the card. What is the possibilities you are expecting after inserting the card? What you are expecting next step? Please respond. Respond in the chat box. Okay, language. Okay. Very good. Very good, Ashutosh. No money in ATM. Very good. So before going to all those options, your card must be valid, right? You may be inserting your college ID card, if possible to insert, or you may be inserting a Shopper Stop card. You may be inserting a central card. You may be inserting some other cards. So card must be valid, right? So first thing is it has to validate the card. Okay, you may be inserting other card also. Okay, right, correct. But so system must validate whether it is valid card or not. So system must be in a position to observe whether the inserted card is valid or invalid. If it is invalid, it has to give the message. What is it here? Invalid card. Right? If it is valid, then it has to go to next step. Otherwise, it should not go. Understood correctly? If it is not a valid card, it should not go further. For other cards also, if it is saying that, select the language and enter the pin and so, if it is giving money for us, then it would be very much happy instead of ATM card, right? So it must be a valid card, then only it must be going further. It must be going further. So what we are expecting here? So system must be in a position to validate whether the card is valid or invalid. Whether the card is valid or invalid, it must be in a position to decide. It must be in a position to decide. That is valid or invalid. Right? If it is invalid, it has to display that it is not a valid card. If it is valid card, then assume that there is no language and all. So let us understand a valid input. So yeah, it may be language also, but not a problem. Let me go to next step. So if it is a valid card, what is the next step we are expecting? Enter pin. Right? Enter pin. Yes or no? Okay. Okay, Pallavi. Okay. So you are in extreme level to analyze. Okay, let me take simple example, simple possibilities only, because our aim is to not to design the ATM machine now, right? That will take some more days or some more time. So once you are completing your PG, then if you become a designer, then you can think all these possibilities. Simply let us understand what is happening, right? Fine. If a card is valid, if the card is valid, then what it has to do? It has to ask for enter pin, right? Enter pin. So again, you may be entering valid pin or invalid pin. Again, it must be in a position to take a decision. What is it here? Valid or invalid? Valid or invalid? If it is invalid, it is invalid. Then think possibilities. If the pin you have entered is invalid, what it does? Yes, correct, Ashutosh. What it has to do? If you are entering pin, if it is invalid, right? Depending on system design, depending on ATM, it might be observed different ways. What is that? Enter valid pin or invalid pin, transaction is cancelled. Depending on system design, there might be two ways how system is responding. So how system is designed, depending on that, it is responding in two ways. One is what is that? Invalid pin, enter valid pin. That is one thing. The second possibility is invalid pin, transaction is cancelled. Then again you need to insert the card. Again you need to swipe the card. That means it is going back to initial, or it may be going back one step back. So already inserted card, it is remembering that information of card. So when you're swiping the card in ATM machine, it is remembering all the information, Now, if you are entering invalid pin, it may be saying that just going one step back, enter valid pin. Or other possibility is second possibility, or different systems are responding differently. So there it may be saying that invalid pin and transaction is cancelled. Then again we need to swipe the card. Otherwise it won't work. But if it is just going back one step back, then it is not discarding the transaction. Still information is available. What is that here? The first information, which is inserted card, that information is there in the memory still. In the memory, it is there still. I hope you are understanding. I hope you are understanding. Are you there? So there are two possibilities. There are two possibilities. That is depending on system design. Depending on system design. That is what is that here? Invalid pin. If it is valid pin, then it is showing that a pop-up window. What is that here? Withdrawal, mini statement, or fund transfer, or whatever it be. Many options will be there. So there you have to choose one. That means what will be the next pop-up window depending on your input. So next state of the system is depending on your input there. Right? Your input, what input you are giving there. So if I say that I'm using withdrawal, if I say withdrawal, then what it does, it is popping up a window to enter the amount, right? So there you are giving an input. If that input is valid or if it is acceptable, then withdrawal it is chosen. Yes, withdrawal you are choosing. Then it is popping up a window to enter the amount. There you may be entering 10 rupees, right? You may be entering that 120 rupees. You may be entering that, right? Any fractions or whatever it be. So which is not possible to dispatch. Again, what is that? It has to check when you are entering the amount, it has to check either it is valid or invalid. Or you may be entering 2 lakhs also. You may be entering 2 lakhs. Then bank limits may not be there. Even though bank is limiting the width of that machine where we are getting that notes, it may not be sufficient to dispatch. Even though bank limits are not there, in one transaction, it cannot dispatch those many amounts. There is a limitation for ATM machine also. That means either it is valid amount or invalid amount. It may be lowest or it may be fractions. It may not be dispatchable, or the amount may be right, multiples of 500, multiples of 100, multiples of thousands. You might have observed enter a valid amount which is multiples of 500. The message in ATM machine. That means it has to know all that possibilities. So depending on your input, whether it is valid or invalid. Unfortunate thing you might have observed if you have gone through this situation. Even though you are entering that 5,000, then it may be saying that enter multiples of 500. enter multiples of 500. That's what you might have observed. The situation, it was a wrong message it was giving earlier. But nowadays, anyway, we are not going to ATM machine. No use of ATM machine nowadays. But so understand this. Even though you are entering that higher amount which cannot be dispatchable, then it was saying that enter multiples of 500. So for lowest message, that is the correct lowest amount. That is the correct message. But for highest message also, or higher message, higher amount also, it was giving same message. That is the wrong thing we observed, and after that it is rectified nowadays. So finally, what is it here? Okay, come out of that. Okay, it may be valid, it may be invalid amount. If it is the invalid amount, it has to say that enter a valid amount, or it may be saying that invalid amount transaction is cancelled. Again, it may be going back to initial, depending on system design. So when you are entering a wrong amount, what it says that it is invalid amount. Then going back to initial, then again we need to insert the card. Other possibility is what is it here? Depending on system design, it is invalid amount, enter a valid amount, or there may be expansion of that message also. What amount it is acceptable also. Depending on system design, what message it is displaying, what state it is moving, by discarding this transaction, going to initial one system, another system is just saying that message, just staying back in the same state. Instead of going further, it is saying that enter a valid input. It is asking for valid input, or sometimes you might have observed it is discarding the transaction, going back to initial. It is also possible. That is also possible. So depending on system design, it can be anything. It can be anything. So finally, what is it here? Right. So that is invalid amount. If it is valid amount, then again you may be observing a message. Would you like to go for print or not required? So if you are depending on your input, right, it has to check the amount. So at the time, what is it here? It is checking the amount from your account. So through internet, it is connecting to the server. If a valid amount is there, then it can dispatch the amount. So you might have observed what is it here? The system has to give control to different robots. So who is counting internally? There is a counting machine from different boxes. So depending on amount, depending on right notes is already predefined in the ATM machine. So in ATM machines, you might have observed only 500 notes. You might have observed sometimes some of the 500 notes and 500 notes are so 1,000 notes. That is already predefined. So depending on your amount, it is counting from each and every box, then connecting and dispatching the amount, collecting and dispatching the amount. So it has to be given control signals to different hands or different box in the ATM machine. So internally, what is it here? So there will be a robo hand, which is counting the number of notes. Then from each and every box, there may be notes and collecting and dispatching the amount. So to get the dispatch or to get the amount from ATM machine, you need to give inputs in a sequence, right? So if inputs are applied in a sequence, the specific operation will be completed. Am I right? So you are not a user now, you are a designer now. Now you need to design a system which is working as expected. Understand correctly? You need to design a system which is giving expected functionality. So according to your inputs, it has to be changing the states. It has to respond. Fine. Right. So finally, what is it here? To give expected output, it has to be applied inputs in a sequence to the system. So each and every input is observed. If inputs are matching with the expected sequence, then it is resulting output expected. Otherwise, you won't get money from ATM machine, right? So after inserting the card, if I enter the amount, not acceptable, right? Depending on system, right? If it is expecting a pin, it has to be given a pin only. But after inserting the card, after swiping the card, you may be entering the amount. It may not be acceptable, right? If it is accepting, fine. If it is not accepting, what is that here? So it is expecting inputs in a sequence. the sequence of inputs are satisfied, then it is resulting expected output. To get expected output, the inputs must be supplied in a sequence only. So I'm giving valid input, but at what time you are giving, that depends on what state system is there. In that state only you have to give expected input. Understand correctly? It must be applied inputs in that particular state only. That means after reaching to that state, how can it reach that state? You need to give inputs in a sequence. When you're applying inputs in a sequence, then it is reaching to the expected output. So finally, what is it here? System is expecting inputs in a sequence, right? System is expecting inputs in a sequence, or you need to design a system which is observing these inputs in a sequence. Now, I need to design a system. I need to design a system. To design this system, what should be observed? Let us see. Then what should we do? Let us see to design this system. Just a minute. Right. So we need to observe, or we need to design a system which is observing sequence of inputs, right? So to understand this, what is the FSM design, system design, we need to understand one more thing. What is it here? How the system is changing the state. To observe this, to understand this, again, I will take a general example. Please focus on this. Everyone should understand this because you need to know how to write state diagrams, then state table, then implementation. That's it. So what is it here? For a given functionality, we need to write a state diagram. From that, we need to write a state table. Then we need to go for design. Try to understand this correctly. Now, a reality show or game and TV shows you might have observed, right? Imagine yourself, you are a celebrity, and you are playing a game, a reality show or a TV shows. What is that game is? Listen carefully, understand correctly. Listen carefully. There is a pipe. To understand that sequence correctly, I'm explaining here. So understand this, sir. So in a pipe, we are getting two colored balls, red and green. Understand correctly? Red and green. We have two colors of balls, red and green. So now, given task is first you need to get red, then you need to get green. Red followed by green. Then you are the winner. Please listen carefully. I have created this to understand this ones and zeros. Why I have used only two colors is we have ones and zeros only. So there is a pipe. In that pipe, we are getting two colored balls. Imagine what ball we are getting, we don't know. Until we get in my hand, then I can see what is the color of that ball. Until that, I don't know what ball I'm getting, which colored ball I'm getting, I don't know. So you are playing a game. The task given is a red followed by green. Imagine correctly. Red followed by green is the sequence we are expecting. So to say that you are the winner, you need to get a red followed by green. Red followed by sequence is expected what? Red followed by green. Red followed by green. Yes. What in the situations? Now you are in initial state. Nothing we got which is required, right? We don't have anything with us. Now we are getting a first ball. Listen carefully. You are in the initial state. What is that initial state? Nothing is found which is required. Nothing we got which is required till now. What is required? We need to get red ball, then we need to get green ball. We are not getting both at a time. We are getting one by one. Please check your mind correctly. How your mind is experiencing different states. What we are going to take the decisions also is important to understand the sequence detector which we are going to design in FSM. See, we are waiting for a ball. We are in initial state. Nothing we got, right? So the first ball may be red, may be green. If you are getting a green, the first ball we are getting a green. What we do? Don't say that I will hold it when I get red, I will arrange. You should not arrange. You should get in order. Don't bluff there, right? TV shows may be doing that bluffing games and so and so. Then they are creating fun. Then they are getting good TRP rates. But here it is not like that. You are not going to do such things here, right? So yes, we are getting a first ball. We are getting a first ball is green. Assume that we are getting a first ball is green. Should I hold it? No, because in the first I don't need green. I need to throw it. I need to throw it. I need to wait for first ball. What is state of mind? What is state of mind? Same as earlier, right? Remember this. Even though I'm getting a green ball is not required as the first ball. Then what I'm doing? Discarding that ball, waiting for first ball again. Waiting for first ball means this initial state. Even though I'm getting a ball, as it is not required for me, I'm discarding that, waiting for first ball. What is state of mind? Same as initial. Remember this correctly. Same as initial. Because I'm not getting which is required. I'm expecting a first ball is red, but I'm getting a green. Then I cannot hold this green, discarding that, waiting for first ball again. Waiting for first ball is what? Initial state. Yes. There is one possibility, getting green ball. Other possibility can be there, right? You need to check all possibility because you are designing the system. Now, other possibility, what is that? You may be getting red ball also. You may be getting red ball. If you're getting red ball, so you need to hold this, right? Because I need a red first. Yes, I got a red. Then I need to hold that. What is your state of mind? Is that initially whatever we have? No. Why? Already we got red means 50% already we win. Right? Understand correctly. We got a red ball. We have a red ball means our mind says that, yes, we got one ball which is required. If you get second ball, yes, we have done. Your mind is saying that it is in next state, right? Whatever the way your mind is experiencing the state, your system must be changing the state. To say that we got which is required red, it is not completed, it is not complete, but we got a red which is required. That means system is in next state. Your mind is in next state. Same way, you need to say that system is in next state. So initial state is there. Initial state is what? Nothing got which is required. But after getting red ball, what you are saying that you need this for meeting expected. You need this. That means, so we need two balls, red followed by green, but we got red. That means your mind is saying that, yes, 50% is fulfilled. How can we say that? By changing the state of mind. So yourself, you are saying that your mind is changing state of mind. So state of mind is changing. Similarly, you need to change the state of the system. So it is in the next state. That is saying that we got a red. We got a red. In that state, it is saying that we got a red. Now, we are in next state of mind. We are in next state of mind. In that next state of mind, that means we have a red. Now, you may be getting red. You may be getting green. Listen carefully. You may be getting red. You may be getting green. Listen carefully. Everything is similar to this. Whatever we are going to do in FSM, it is depending on this only. Yes, we have a red. And next we are waiting for next ball. Which state we are? Not the initial. We are in the next another state than initial. In the initial, nothing was observed. But now we have a red that is in another state than initial state. Now we are in next state. There we are looking for another ball because required is what? Two balls, red followed by green. So in the next state means we have red. Now you may be getting red. You may be getting green. If you're getting red. Red followed by red, not required. Then discarding everything. No. Because red followed by green is required, but we got red followed by red. Then what should I do? Discarding earlier red, holding recent red. Why? Why? With this recent red, it may be followed by green. That is the reason. What is it here? In the second state, so we have a red. Again, we are getting red. Two red is not required in a sequence for our pattern. Then discarding earlier red. Discarding earlier red. Not the recent one. Discarding earlier red, holding recent red. What we have here? Only one red which is required. Already we have decided a state for this, right? So even though we are getting two red, your mind is saying that which is not giving anything extra towards winning the game. So already we have a red. We are getting another red. Two red is not required, right? So what should we say that discarding earlier red, holding recent red, holding recent red. Then your state of mind is same as earlier. Which one is that? Already we are saying that we have a red. Again we are getting red, but because of this, it is not changing state of mind, because we need only one red. Even though we are getting two red, we need only one red. Then discarding earlier one, holding recent red, holding recent red. So state of mind is same, because towards winning the game we have only red only. Already we had that. Again we are getting no use of that. So discarding earlier one, holding recent red. So state of mind is saying that it is same as earlier. Right? Now in that state, red possibility is done. Next possibility is what? Green. So if you are getting a green in the next state where we have red, in that conditions, if you are getting a green, then red followed by green. Yes, sir. Completing. Then what we do? You are the winner. So you need to make output is 1 in the system. But in this, what we say, reality show or game, what we say, there will be a buzzer. We are pressing the buzzer. Not only once. For example, it is conducted for 10 minutes. In the 10 minutes, if you are getting the 30 balls, in the 30 balls, you need to observe red followed by green. So how many times we are getting red followed by green? Those many times you are going to press the buzzer. It is counting. At the end, it is saying that how much is the count. Similarly, here also, what is it? Wherever it is getting that bits expected, those many times it has to result output is 1. Right? Repeat once again. Understand correctly. What is it here? What sequence you are expecting? What sequence you are expecting? If the sequence is satisfied, you need to change the state. You need to change the state. So once you are completing the sequence there, it is making output equals to 1. Right? There only you can say that I won, right? So for that, whatever the way we have understood the red followed by green sequence, the same way we can understand 1 followed by 0. For example, if you want to design 1 followed by 0, the sequence detector 1 followed by 0. So understand correctly how we are going to write a state diagram. So I am writing state diagram for a sequence 1 0, a sequence 1 simple sequence. I start with simple sequence. Now already I mentioned initial state S naught. Let me say that initial state S naught. Listen carefully. So S naught is initial. What do you mean by this, sir? Nothing is found which is required. So on serial input data, we are not getting 1 0 at a time. We are getting bit by bit serially. In that serial input data, if it is observed 1 followed by 0, there it has to result output is 1. There it has to result output is 1. S naught initial state. In this, we say nothing is found which is required. Now you may be getting 0, you may be getting 1. Am I right? In this initial state, nothing is found which is required till now. In that, you may be getting 0, you may be getting 1. If you are getting 0, for a sequence 1 0, first bit is 0. Do you accept that? No. 0 is not required. As a red followed by green is expected, if you are getting green ball first, what we have done? Discarding that. Discarding that, staying in the same state, right? Your mind is saying that nothing is found which is required. So what is this S naught is the initial state, which is saying that nothing is found which is required. In that state, for 1 0 sequence, if you are getting a 0, if you are getting a 0, if you are getting a 0, then what should I do? Discarding that 0, you should say nothing is found which is required. Then which state is that? S naught only. What I'm saying here, 0 is input. I'm writing that when 0 input is there and it is going to the same state, which is saying that 0 is not required, I'm discarding that 0. So what is S naught significance? Nothing is there. Nothing is found which is required till now. So S naught is initial state. Nothing is found which is required. So in that state, if you are getting a 0, 0 is not required as the first bit. Then discarding that 0, it is staying in the same state, saying that it is not required. So S naught is what? Nothing is found which is required. Even though we are getting 0, you are saying that nothing is found which is required. So 0 is discarded. What about output? Is also 0. When can we say output is 1? Once it is completing that entire sequence, we can say output z equals to 1. Right? You understand correctly? Once we are getting that, what is it here? Entire sequence is observed. There we say output is 1. So here we are writing that x by z. What is it here? X by z. Understand correctly? X by z. X is input, output is z. Z becomes 1 when you are observing that entire sequence. Entire sequence. Am I right? Are you observing? When you are getting a 0, 0 is not required as the first bit, saying that it is staying in the same state and output is 0. output is 0. Now, in this S naught, the initial state, you may be getting 1 also. If you're getting 1 is required to remember because it is starting with 1 only. So, if you are getting a 1 should be remembered. As we discussed, if you are getting a red, holding that red, state of mind is changing. Similarly, state of system also must be changing because it must be saying that we got a 1 which is required. So 1. What about output? It is not 1. It is partially completed. If it is fully completed 1 0, there we make output is 1. So 1 by 0. What is this 1? Input we are getting 1. So as input is 1, as 1 is required to be remembered, how it can remember? By changing the state. Now S1 significance is what? We got a 1 which is required. So S1 is saying that it is not initial conditions. What is it here? S0 is having a significance which is different from S0, which is different from S0. S0 is saying that nothing is found which is required. But S1 is saying that we got a first bit which is required. So S1 is saying that first bit is required is already we got. Now, so from S0, if you're getting 1, said it is moving the next state and output is 0. Now, 2 possibilities in S0 is completed, right? 0 possibility, 1 possibility. Coming to S1. In this S1, again, you may be getting 1, you may be getting 0. So what is that S1 significance? Already we have a 1. Observe correctly, follow correctly what I've been doing. Everyone. So S1 means already we have a 1. Now in this, you may be getting 1, you may be getting 0. If you're getting 1, appending the bit we are getting. So first of all, we need to understand what is significance of respective state. What is S1 state? Already we have a 1. Already we have a 1. S1 significance is already we have a 1. Now you are saying you are getting a 1. So appending the bit which we are getting, then 1 1 is not required for our pattern. For example, if it is 1 1 0, 1 1 is also required to be remembered. If the pattern is 1 1 0, I need to remember this 1 1 also because 1 1 is required for 1 1 0. But here for 1 0 pattern, so 1 1 is not required. Then what should I do? I cannot use this 1 1. So I can discard earlier bit. I can discard earlier bit. Now we have a 1. Now we have a 1. So this 1 is required. Which state is that? S1 state only. So for 1 0 pattern, 1 is required. Because next bit you may be getting 0. There is a reason I need to hold the recent one. Don't discard everything. Start discarding earlier bit. Any partial bits of this are useful or not, we need to observe. Yes, 1 1 is not required. Discarding earlier 1 is required. So required, how can you say that? Staying in the S1 state. What is that now? 1 by 0. Why output is 0? Still it is not completing the sequence. So S1 statements already we have a 1. You are saying you are getting another 1. If you are getting 1, 1 1. 1 1 is not required for our pattern. Now start discarding earlier bits, not the recent. So discarding 1. Now 1 is required. 1 is required means which state is that? S1 state. Now 1 possibility is completed from S1 state. Now S1 already we have a 1. You may be getting a 0 also. Another possibility. Yes, sir. We are getting 0. 1 0 is required. 1 0 is required. Then you need to make output is 1. You need to make a output is 1. Then going back to S0. Why? Again, it has to check for next pattern, right? 1 0 is observed, correct, but it has to check for next pattern. Next pattern. Check it correctly. So again, going back to S0 for checking one more 1 0. So after getting red followed by green, what we do? We cannot stop there because you may be getting again red followed by green. So in the entire sequence of bits, you need to observe 1 followed by 0. Then what is that here? Once we get red followed by green, we keep it aside. Then we go for next sequence of red followed by green. Similarly, the system also must be observing 1 followed by 0 in the entire serial input data. In the entire serial input data. Am I right? Is there any doubt? Is there any doubt in this 1 followed by 0? Please respond. Anyone has any doubt in writing state diagram for 1 0 pattern? Shubham, always you are at next levels. So from S1 that no S1 we are not getting 1 0. From S1 means already we have a 1. If you are getting a 0 input, 1 0 is completing the pattern. From S1 means already we have a 1. Now you are saying that getting a 0. X is input. X by Z we are writing. X is input. So already we have a 1. We are getting a 0. 1 0 is completing the pattern. There we can make output is 1. That is the reason 0 by 1. X by Z. X is 0. Z is 1. So from S1 means already we have a 1. You are getting a 0. 1 0. 1 0 is completing the pattern. There we need to make output is 1. Yes. Yeah, no, Kumar, it is wrong. Right? If it is RGB, red, green, blue is required. If you have that red and green, then what is it here? I got red, you are saying. If you get red, yes, discarding R and G, holding only red, correct? Holding only red. RGB is required. Simple sequence is what? RGB is required. If you are saying that RGB. So after getting RG, if you are getting R, don't discard this R. Right? So what is it here? RGB is required. You are getting RG, you are saying. Now you are getting R, then don't discard this R. Start neglecting this one. Yes, discarding this R. GR is not required. For sequence GR is not. G neglect. Then R is required. So hold this one only. That we understand next. Kumar, we are going to understand that. Please wait. Bhavani. From S0 to S1 getting only 1. Not 1 1. So that is not the way you are expecting it will be. It is giving a different arbitrarily, it is giving ones and zeros. Then which one will be given, we don't know. We need to think all the possibilities. Bhavani, don't think that the way you are expecting, because we are looking for 1 0, it must be giving 1 0 only. That means you are feeding 1 0, no? Someone is giving that serial input data. On that serial input data, you need to observe a pattern. So it is not the way you are expecting. Please, Bhavani, you need to think that. Yes, increasing Pawan Kumar. That's what we are going to do. Next is that only. We are going to understand clearly everything. Please wait. If I change that pattern, then you will understand. Please wait. Now, I change the pattern instead of 1 0, higher number of bits let me use. Let me use 1 1 0. Let me use 1 1 0. The sequence is now 1 1 0. Listen carefully. 1 1 0. 1 1 0. The sequence is 1 1 0. Listen carefully and let me do that. S0 initial state. S0 initial state. What do you mean by initial state? Nothing is found which is required till now. In that, you may be getting 0, you may be getting 1. Each and every state has its own significance. S0 initial. Nothing is found which is required till now. In this, you may be getting 0, you may be getting 1. If you are getting 0, what should I do? 0 is required as the first bit. No, discarding that 0, say that nothing is found which is required. So first bit we are expecting 1, but you are getting a 0 here. Yes, not initial. Nothing is found which is required till now. If you are getting a 0, what should I do? 0 by 0. 0 by 0. Correct? 0 by 0. Yes. So it will be in the initial state only. It will be in the initial state only. You are getting a 0. 0 is not required as the first bit. Yes, discarding that 0 and we are staying in the same state. If you are getting a 1 in initial state, if you are getting a 1 should be remembered. From S0, if you're getting a 1, what is it? Required to be remembered. What is the output? 0. What is significance of S1 now? Already we have a 1. Remember this correctly. Each and every state I'm saying that what sequence is already completed. So S0, nothing is found which is required till now. If you're getting a 0, not required, stay in the same state, saying that nothing is found which is required. Now from S0, if you're getting a 1, 1 is required as the first bit. So required to be remembered. How it can remember? By changing the state. You are remembering by exciting your mind. System is remembering by changing the state. So S1 is what? Already we have a 1. S1 significance is what? Already we have a 1. In this S1 state, you may be getting 0, you may be getting 1. If you're getting 0, already we have a 1. Right? S1 significance is what? Already we have a 1. You are getting a 0. 1, 0. Is it required? Not required. Is it matching with the pattern? 1, 1, 0 is pattern. Is it possible to use 1, 0? No. It is not 1, 0, right? So now you don't neglect immediately all. What should I do? Discarding this 1, earlier bits, 0. 0 is also not useful as the first bit, discarding this. So everything is discarded. Then going back to initial again. Check it correctly. How we are neglecting the bits. From S1 means already we have a 1. Now you are getting a 0. 1, 0. 1, 0 is not required. Then discarding 1. 0 is not required. Discarding this, nothing is required. So again start freshly from first bit. See, don't say that we have 1, 0, discard 0, hold 1. It is not possible. It is not possible. It is not possible. Check it correctly. Am I right? In S1, we are getting a 0. 1, 0 is not required. Then what should I do? Discarding 1. 0 is also not required. Discarding everything. Going back to S0. Because now, even though we are getting 1, 0, that is not useful for our pattern. Discarding everything. Then going to initial. Because again start freshly from first bit. From S1. From S1. You may be getting 1 also. What do you mean by this S1? Already we have a 1. We are getting another 1. 2 1s. Yes, 2 1s is required. Another possibility from S1. S1 means already we have a 1. You are getting another 1. 1 1 is required. 1 1 is required means required to remember. S1 is not saying that 2 1s. S1 is saying that only one input is 1. Already we observed only 1. No, I have now 2 1s. It is not completing the pattern. Then remembering the state. Remembering with another state. What is it here? 1 by 0. Still it is 0 only because it is completing 1 1 0. There we say that the output is 1. But now here it is only 1 1 is completed. What is significance of S2? Already we have 1 1. Already we have 1 1. Try to understand correctly. Already we have 1 1. Significance of S2 is what? Already we have 1 1. In this, you may be getting 0, you may be getting 1. You may be getting 0, you may be getting 1. So already we have 1 1. If you are getting a 0, already we have 1 1. If you are getting a 0, what is it here? 1 1 0 is completing the pattern. Then we need to make output is 1. Again start freshly from first bit. It is a 0 by 1. 0 by 1. Check it correctly. So S2 is already having 1 1. So now you are getting a 0. 1 1 0 is completing the pattern. Yes, we are making output is 1. So another possibility. S2 means already we have a 1 1. In this, you may be getting another 1. 1 1 1 is not expected. Then what should I do? Start neglecting a little bit. 1 1. Yes, useful. 1 1 is useful. See, S2 means already we have 1 1. Now you are getting another 1. 1 is not required. But if you are discarding earlier bit, 1 1 is required for our pattern. So 1 1 should be remembered. Which state is that 1 1? S2 state. So even though you are getting another 1, discarding that 1. So staying in S2 state. Remember, you need to discard earlier bits, not the recent. Earlier bits can be discarded. So now it is completing. Anyone has any questions? So what is S0 significance? No bits are found till now. What is S1? We got a 1 which is required. What is S2? We got 1 1. In S2 state, if we are getting a 0, yes, 110 is completing, then we are making output is 1. So again, starting for next pattern or next sequence in the serial input data. In the serial input data. Anyone has any questions here? Right? S2 can be connected to S1. So you want to merge these two? Pawan, why do you want to match those? S1 significance is already we got a 1. It is separate. S2 significance is what? Already we have 1. How can I match this? No. It is having a separate meaning, right? S1 is having separate meaning. Right? Yeah. So, yes, understood. What is that your doubt? I understood. So, yeah, doubt is what is see, after getting 1, if you are getting 1 from S2, if you are getting 1, so now I neglected this, I have used 2 ones, so S2 state. And someone is saying that instead of neglecting 1, I can neglect these 2 and use only 1. But what happens? Let us see. For example, do we have 110 in this? Yes, we have 110. Where do we have? This is a 110, right? See correctly. This is 110. What happened here? We got a 1, we got another 1, we got 1. Now, if I'm discarding this, we have only 10, then system cannot say that 110 is there. Remember that correctly. So, Pawan, what you are saying that discarding these 2 ones, hold this only 1. Now, next if you are getting 0, 10 is there, 110 is not there. That possibility you are missing, right? In this serial input data, 110 is there. When can we say that? When we are getting 111, discarding this 1, if you are holding these 2 ones, then when you are getting 0 now, 110 is observed. If you are saying that discarding these 2 ones, if you are remembering only 1, so 10, so it cannot be observed 110 which is there here. Right? Pattern in serial input data. Bhaskar, that's what I said. What is it here? What you are saying that we got a red, green, we got a green, red. Then what you say that you are arranging by reverse order? No. You should get in a sequence. Bhaskar. So don't try to that manipulations I'm saying. You cannot discard coming bits because with the coming bits you can make a pattern with the coming bits. So with the recent bits we can use, but with old by discarding recent is not possible. Right? Check it correctly. Bhaskar, don't do that mistake. Right? S1 state it again go through S2 state now. Yeah, I will talk to you, Pawan. Please wait. From S1 0/0. From S1 0/0. Listen carefully. From S1, what is S1? What is S1 significance? Already we have a 1. Already we have a 1. Now if you are getting a 0, 10, is it required? Is it forming a pattern 110 with 10? Don't say that I have at 10 here. No. I cannot append this side. I can append this side bits. The coming bits can be appended right side. So with 10, can I make 110 by appending bits right side? Is it possible? No. Check it correctly. So S1 is already we have a 1. Now you are getting a 0. Now 10, can I use this for making 110 by appending bits right side, not the left side? Left side is not possible. left side is not possible to append because coming bits always you need to append in the right side only. Right side only. So I cannot append this side. So 1 0 is not useful. So discarding this 1, 0 is not required. Discarding this 0 also. Then nothing is there which is required now. Then going back to initial. Param. Why Shubham Kumar? What happened? Why do you want to stay in S1? See, people are understanding that 1 0 is there. Now I discard this. How can I discard this recent one? I can discard earlier one. So I am arranging in a sequence. I can delete this which are earlier. I cannot delete this recent. Remember this, right? What is here? First in, first out. First in, first out. It's a queue. So I can discard earlier, not the recent. Remember this point. It is not like waiting. It is not like waiting. You are not there. System is there. System is not having that intelligence to wait until we get that only. Remember this correctly. People have been thinking that in S1, people are thinking that you are getting a 0. Don't take it. No, it is not like that. We are getting that we have to accept. System has to accept. Don't say that. So you have intelligence that I don't need to discard that. So if you are in S1 state, if you are getting a 0, then what we say, 0 is not required. I don't take it. It is not like that. Shubham. It is not like that. So people are understanding that. Sorry, wait. Just a minute. No, it is not in our hand, Dinesh, correct. The serial data is supplied. Yes, we can discard bits which are earlier. Sorry, I opened a wrong one. Right? We can discard earlier. That is, we can discard from left side. We can append right side only. We can append right side only. Yes, Dinesh, 100% correct. So Arpitanand, just now I mentioned. So in what is it here? S2 state. In S2 state means already we have in S2 state means already we have 1 1. Now you are getting a 1. Why do you want to discard everything? Because if next bit is 0, 1 1 0 is there, right? If you are discarding everything, what happens here? The 1 1 0 is missing, right? So remember this. I will make a statement. Right. Listen. When it is not matching with the pattern, when you are getting bits, when it is not matching with the pattern, then don't discard everything. Start neglecting earlier bits. Observe how many maximum number of bits can be used for next pattern. See, when it is not matching with the pattern, then don't discard everything immediately. Start neglecting earlier bits. So how many maximum number of bits are useful for pattern? Utilize that. Depending on that, it is going to the respective state. Respective state. Right. Surya Teja, I did not understand your question. The only thing is, what is it here? In a serial input data, it must be found the sequence without fail. Without fail. Without fail. So each and every thing, what is it here? When you are in a state, particular bits already observed. Listen carefully. State is saying that already we observed some bits. From that, you may be getting 0, you may be getting 1. If it is matching with the pattern, going to next state. If it is not matching with the pattern, then listen carefully. Two things only. Two things very easy. So we are in a state. That state is having a significance. That means we got some bits which are required already. Now, from that state, you may be getting a 0, you may be getting 1. If you are getting a 0, appending 0 right side, observe. Is it useful for the pattern? If it is useful for the pattern, use next state to remember that. When new bit is useful, then going to next state to remember. Because that state is having significance up to that bit only. So one more bit useful we are getting, then going to next state to remember that bit also. So each and every state is having its own significance till how many bits it is satisfied. That's what it is saying. So when it is satisfied, moving to next state. When it is not satisfied, don't discard everything immediately. So start neglecting earlier bits. So how many maximum bits from these are useful for the pattern? Depending on that, it is moving to next state. It is moving to next state. So if it is useful, going to next state. If the bit is useful, going next state. If bit is not useful, appending that, then every time appending that, discarding earlier bits. So observing how many bits are useful from these to the pattern. That's it. So what I said here, so S2 is already 1, 1. So listen carefully. S2 is already 1, 1. Many are having this doubt. Let me clear that. So S2 is having, what is that here? S2 is saying we got already 1, 1. Now, when you're getting a 0, completing the pattern, correct? But when in S2 state, that means already we have a 1, 1 if you're getting 1, 1. So 1, 1, 1 is not matching with our pattern, right? 1, 1, 1 is not matching with our pattern. Then what should I do? Don't discard everything. Then what should I do? Discarding earlier bit 1, 1. Can I use 1, 1? Yes. For 1, 1, 0, 1, 1 is useful. So 1, 1 should be remembered. Even though we have 1, 1, 1, I'm discarding this 1. So I'm using only 2 1s because only 2 1s is useful for the pattern. So it is staying in the same state. Maximum bits. From that sequence, maximum bits which are useful for the pattern should be remembered. Depending on number of bits, it is going to the respective state. When it is not matching. When it is matching, trying to remember by changing the state. If it is already completing, making output is 1. Making output is 1. Listen carefully. Right? Yes. So when you are in, listen carefully. Everything is, when you are in a particular state, that is having a significance. That means already we got up to some bits. So that pattern is already there. So a respective state is saying that till what bit we got. So with that, you may be getting a 0, you may be getting 1. So again, if you are getting a bit which is expected, then going to next state for remembering. If you are getting a bit which is not expected, so from that state, you are expecting either 0 or 1. If you are expecting a 0, moving next state. If you are getting a 1, no. Because, so you are expecting a 0 from that state. Because S1 already, we have a 1. So now, after getting 1, next bit, what are you expecting? 1. If you are getting 1, it is useful. Moving to next state. If you are getting a 0, it is not useful. Because already we got a 1. Now you are getting a 0. 1, 0 is not useful for the pattern. Then what should I do? Start discarding this. 0 is not useful. Then both are not useful. Then again start freshly from first bit. That means S0. So it is matching with the pattern or the bit we are expecting. If you are getting, remembering. If the bit we are not expecting, we are getting, then so take a decision. What is it here? What should I do? Start neglecting earlier bits. Start neglecting earlier bits, not the recent bits. Not the recent bits. Try to understand correctly. Try to understand correctly. Right. Now you can type if you have any more doubts. Only two things. If you are getting expected bit, moving to next state to remember. If you are not getting expected bit, then from that appending the bit, then we need to take a decision. So by discarding earlier bits, we need to observe how many bits are useful for our pattern. Depending on number of bits, we need to move to next, right? Expected state. Expected state. Okay. People have a message. Okay. Very good. Hold on. I'm going to that only. Hold on. Hold on. Kumar, that's what I'm doing. Wait. That's what I'm going to do. Again, we have two problems there. It is not there, Abhijit. In the recent syllabus, it is not there. Abhijit, it is removed from the syllabus. Don't care, will not be there, Shubham. Yes, I'm going to do that, Prashant. Now, we are going to understand one more concept with this. What is it here? 1101. If I say 1101, if the sequence is 1101, what should I do? If the sequence is 1101, if the sequence is 1101, now let us see what happens. Now let us see what happens. 1101. 1101. Try. Yes, not. Initial, nothing is found which is required. Then, if you are getting a 0, 0 is not required as the first bit. Discarding that 0, stay in the same state. In yes not state, if you are getting 1, should be remembered because 1 is required as the first bit. Then it is going to another state, S1 for logic 1. For logic 1. What is the output? 0. Right? Now you are in S1 state. You are in S1. What is S1 state? We got already 1. We got already 1. So now in this, you may be getting 0, you may be getting 1, you are getting a 0. 1, 0 is not useful. So after S1 state, you are expecting a 1, but we are getting a 0. So after S1 state, you are expecting a 1, but we are getting a 0. It is not required. Then discarding earlier bit. 0 is not required, right? Discarding this. So nothing is required. Go back to S0. What is it here? 0 by 0. 0 by 0. Now S1 state. What is it here? S1 state. S1 state. In S1 state, 0 possibilities. In S1 state, if you are getting 1, already we have a 1, S1. You are getting a 1. 1, 1 is expected only. So should be remembered, right? So how it is a S2 state? As observe correctly, what is it here? It is 1 by 0. Expected bit, so remembering, right? 1, 1. Yes. Now S2 state. Now S2 state means what? Already we have 1, 1. Significance of S2 is what? Already we have 1, 1. Now you may be getting 0, you may be getting 1. If you are getting 0, 0 is expected or not expected? Expected. Because after S2 means already we have 1, 1. If you are getting a 0, 1, 1, 0 is expected. So remembering by changing the state. By changing the state. What is here? 0 by 0. 0 by 0. Right? Now in S2, 0 possibility is completed. 1 possibility is there. So S2 means already we have 1, 1. If you're getting another 1. 1, 1, 1 is not required, right? Then what should I do? Don't neglect everything. Neglect earlier bit. 1, 1 is useful. 1, 1 which state is that? S2 state only, right? So this is what you write. Check it correctly. Right? In S2 state means already we have 1, 1. You are getting a 1. 111 is not required for our pattern. So then what should I do? Discarding earlier bit. 1, 1 is useful. Yes, it's staying in the same state. Now, S3 state. Important, listen to me. From S2, 0 possibility is completed, 1 possibility is completed. In S3 state means already we have 1, 1, 0. In S3 state means already we have 1, 1, 0. Now you may be getting 0, you may be getting 1. You may be getting 0, you may be getting 1. Listen carefully. If you are getting a 0, is not expected because after 1, 1, 0, from S3 state, you are expecting a 1. What is the S3? Already we have 1, 1, 0. Now you are getting a 0. Is not expected. So what should I do? Discarding this 1, 0, 0. Is it useful 1, 0, 0? No. Discarding this 0, 0. Is it useful? No. Discarding 0. Is it useful? No. Nothing is useful. Then go to yes. Now listen carefully. Observe carefully what I am doing. Yes. Right. That is from S3 set, if you are getting a 0, what is that here? S3 means 1, 1, 0. You are getting a 0. It is unexpected bit. Then start neglecting early bits. 1, 0, 0 is not useful. 0, 0 is not useful. 0 is not useful. Nothing is useful. Then go back to S0. Now, in S3 means already we have 1, 1, 0, right? Already we have 1, 1, 0. If you are getting a 1, if you are getting a 1, if you are getting a 1, useful, right? So you need to make output is 1. You need to make output is 1. But where it has to move? Where it has to move? Sorry, I wrote wrongly, right? Hold on. Yes, sir. It is 0 because it's not completing the pattern, right? Yes, it is 0. Now, from S3 statement, you are getting a 1. S3 means 1, 1, 0. You are getting a 1. 1, 1, 0, 1 is completing the pattern. Then you need to make output is 1, right? But where it has to move? Where it has to move? For that, again, we have two possibilities. What is that? Let us see. Listen carefully. How many times 1, 1, 0, 1 is there in this? Please respond. How many times 1, 1, 0, 1 is there in this? How many times 1, 1, 0, 1 is there in this? How many times 1, 1, 0, 1 is there in this? Yes, Revant, I have written. Thank you. Thank you, Rajita. Thank you. Right. So, how many times 1, 1, 0, 1 is there in this? 1, 1, 0, 1, 1, 1, 0, 1. Twice, right? Twice. Or you can say like this also. In the serial input data, 1, 1, 0, 1. 1, 1, 0, 1 is observed, then only once. But here you are saying 2 times, here it is 1 time. Then what is this? What is this? Some of you are already started responding. Yes. So 2 times means, what is it? Very good, Sai Kumar. Very good. 1, 1, 0, 1. Surya Teja. Where do you have 3 times? 1, 1, 0, 1. 1, 1, 0, 1. So this is called overlapping. This is called non-overlapping. So if you say only once 1, 1, 0, 1 is there, then once 1, 1, 0, 1 is observed, discarding everything, start freshly from first bit, then going to S0. So that is a non-overlapping. If you are observing any of the bits are useful for the next pattern, or after observing the pattern, if you are utilizing some of the bits for the next pattern, then it is called overlapping. In overlapping, 1, 1, 0, 1 is there twice in this serial input data. So 2 times you are expecting output 1 means it is overlapping pattern. If you are expecting only once output is 1, that is a non-overlapping. What do you mean by this? Once 1, 1, 0, 1 is observed, discarding everything, start freshly from first bit. Then it is not possible to observe second time 1, 1, 0, 1. But if I use overlapping, or if I use some of the bits from this pattern for next pattern, then it is called overlapping. See, if it is overlapping, what happens here? Let us see. 1, 1, 0, 1 is observed. Yes, you need to make output z equals to 1. Correct? But after observing 1, 1, 0, 1, start discarding earlier bit. 1, 0, 1, is it useful? No. 0, 1, is it useful? No. 1, is it useful? Yes. With 1, we can start with the 1 next pattern. So 1 should be remembered for next pattern if it is overlapping. Then it is what is it here? 1 by 1. What is this? Overlapping, because I'm using 1 bit which is required for next pattern. So Overlapping means a maximum number of bits useful for the pattern should be utilized. Maximum number of bits useful for the pattern for the next pattern should be utilized. Maximum means I use 1101 all. So already we made output is 1 for 1101. From that, start neglecting from earlier bits. How many maximum number of bits can be used for next pattern in overlapping design? Non-overlapping, discarding everything. Start freshly from first bit is nothing but going to initial state. It is what is here 1 by 1. Red one is what non-overlapping. This is a non-overlapping. The blue one is a overlapping. Blue one is overlapping. Check it correctly. Overlapping, non-overlapping. Overlapping, non-overlapping. Right? So if it is overlapping, you need to observe how many maximum number of bits can be used for the next pattern. If it is non-overlapping, discarding everything, start freshly from first bit. After observing entire pattern, two possibilities. So if it is possible to, or if it is required to use overlapping, then start neglecting from earlier bits. Maximum number of bits useful for the next pattern should be utilized for next. If it is non-overlapping, discard everything, start fetching from first bit again. But why didn't you discuss earlier about overlapping? Is it possible overlapping in 110? Discarding 1 0 is not required. Discarding 1 0 is not. Discarding this. So overlapping, non-overlapping, both will be same for 110. For 10 also same. Discarding 1 0 is not required. Discarding 0. So start freshly from first. Overlapping, non-overlapping will be same for 10 and 110. That is the reason I did not address here overlapping. So in this, there is a possibility for having overlapping sequence. Overlapping sequence. Check it correctly. Are you there? Overlapping or non-overlapping? Yes, correct. Yes, correct. Very good, Surya. Very good. Overlapping and non-overlapping. Please complete a state diagram for 11011. 11011. Please complete a state diagram for 11011. Please write state diagram for 11011. No, it must be specified either it is overlapping or non-overlapping. Shubham, it must be specified either it is overlapping or non-overlapping. Right. I am writing. Please follow my analysis, sir. Listen. Start initially. Yes, not right. Yes, not. You may be getting 0, you may be getting 1. If you are getting 0, if you are getting a 0, yes, not initial state, if you are getting a 0, 0 is not required as the first bit, so 0 by 0. If you are getting a 1, if you are getting a 1, required to remember, then S1 for logic 1 by 0. From S1, you may be getting 0, you may be getting 1. What do you mean by this, sir? Already we have a 1, if you are getting a 0. 1 0 is not required, so discarding a little bit 1, 0 is not required, so again back to S0 for 0 by 0. In S1, if you are getting 1, S1 means already we have a 1, we are getting another 1. 1 is required, expected bit is that, so required to remember S2 for logic 1. Output is 0. Output is 0, right? So from S1, 0 is completed, 1 is completed. Now S2 means already we have a 1, 1. Now in this, you may be getting 0, you may be getting 1. 1, 1, if you're getting a 0, 1, 1, 0 is expected. So required to remember. So S3. S3. Because required. Because required to remember. Right. In S2 means already we have a 1, 1. If you're getting a 1. So in 1, 1, you are expecting a 0. You are not expecting a 1. So 1, 1, 1 is not required. Then discarding 1, this 1, 1 should be remembered. Because with 1, 1, you can make a pattern. So which state is that 1, 1? S2 state. So staying in the same state for 1 by 0. Or 1 by 0. Right? Now, S3 state means already we have a 1, 1, 0. 1, 1, 0 we have. Now you may be getting a 0, you may be getting 1. If you are getting a 0, 0 is not expected bit. Because after 1, 1, 0, you are expecting a 1, you are getting a 0. Then discarding this 1, 0, 0 not required. Discarding this 0, 0 not required. Discarding this 0 not required. Discarding this, nothing is required. Go back to S naught for 0 by 0 from S3 state. From S3 state. Listen carefully. S3 means 1, 1, 0. You are getting a 0. If you are getting a 0, then what is that? 1, 1, 0, 0 is not useful. Then discarding earlier bit 1, 0, 0 not required. Discarding 1, 0, 0 not required. Discarding 0, 0 is not required. Discarding this, nothing is required. Right? Now, in S3, if you are getting a 1, what is it here? S3 means 1, 1, 0. If you are getting a 1, 1, 1, 0, 1 is required. Required to remember. Then S4 for 1 by 0. Now, S4. Now you need to analyze S4. Listen carefully. S4. What is it here? S4? 1, 1, 0, 1 already observed. Now you may be getting 0, you may be getting 1. If you're getting 0, it is not an expected bit. Then start neglecting this. 1, 0, 1, 0 not required. 0, 1, 0 not required. 1, 0 not required. 0 not required. Nothing is required. Go back to yes. For 0 by 0. 0 by 0. Right. Now from S4, what is it here? 1, 1, 0, 1. If you're getting a 1, if you are getting a 1, then what is it? 1, 1, 0, 1, 1 is required. It is required. Then where it has to move? Where it has to move? Depending on overlapping or non-overlapping. If it is overlapping, you need to make output is 1. So where it has to move? Let us see. Discarding this 1, 0, 1, 1 not required. Discarding 1, 0, 1, 1 not required. Discarding 0, 1, 1 is required. 1, 1 is required. So it is going to 1, 1 state. Which one is that? S2 state. Oh. In overlapping. If it is non-overlapping, discarding everything, go back to S naught. Right. Very clear. Here now I can use 2 bits. Maximum bits. Don't say that only one I use. No. You have to use maximum number of bits. Overlapping means maximum number of bits. You can use only 1 bit is 1. No. I want to use 2 bits because with 1, 1, I can make a next pattern. So maximum number of bits should be utilized. So red one is non-overlapping. Blue one is overlapping. Yes, correct, Manisha. So Venkat Brahmareddy, if you want to go to S1, you are using only 1 bit. It's a problem again. So I have to use maximum bits. That is important thing. Draw a state diagram for 111. Please complete this triple one. Draw a state diagram for triple one. Draw a state diagram for triple one. Why do you want to go to S2 from S3? If required, we use, but not compulsory from S3 to S2. When condition is not satisfied, compulsory it should be go back to only one state. No, I did not say that. Depending on bits only. Depending on bits only, we have to decide. Pratik Pramod. From S3 to S2, why do you want to go? If it is required, then we go to S2. But not compulsory, it must be going to S2. I did not say this, sir. Don't assume your own assumptions, sir. For triple one, draw state diagram. Shubham, please wait. Shubham. I need to write a state diagram for triple one. 1, 1, 1. Yes, not. Listen carefully. Yes, not. If I'm getting a 0, 0 is not required as the first bit. So discarding that. If I'm getting a 1, required to remember. I'm writing, right? 1 by 0. 1 by 0. From S1. So from S1, you may be getting 0, you may be getting 1. If you're getting 0, right? 1 followed by 0, not required. Both are not required. Going back to S0, 0 by 0. In S1, if you are getting a 1, already we have 1, we are getting 1. 1, 1 is required. Then S2. What is it here? 1 by 0. From S2 again, what is it here? Already we have 1, 1, you are getting a 0. 1, 1, 0 is not required. Discarding this, 1, 0 not required. Discarding this, 0 is not required. So go back to S0 again for 0 by 0. Right. From S2, if you are getting 1, 1, 1, 1. From S2, right? If you are getting 1, what is it here? 1, 1, 1. Am I right? So 1, 1, 1, where it has to move? From S2, if you are getting a 1, 1, 1, 1, yes, triple 1, yes, sir. You can make output is 1, but where it has to move? Depending on overlapping and non-overlapping. So if it is overlapping, discarding 1, this 1, 1 can be used for next pattern. So it's staying in the same state, 1 by 1. If it is overlapping, if it is non-overlapping, going back to this. What is it here? 1 by 1. So in one system, we cannot have both overlapping and non-overlapping. It can be either overlapping or non-overlapping. See, after getting triple one, discarding everything, going back to S0, if it is non-overlapping. If it is overlapping, so getting 1, 1, 1, getting 1, 1, 1. Because S2 is already we have 1, 1, we are getting another 1. We are getting another 1. Now, in this, we observed entire pattern. You need to make output is 1. Where it has to move depending on overlapping or non-overlapping. If it is overlapping, discarding 1, 1, 1. So 1, 1 is useful for next pattern. So staying in S2 state. Staying in S2 state. Right? Very good. Very good. Very good. Yes. Yes, Manisha. You're right. Yes, they have to mention Shivalila. They have to. Very good, Bhavani. Bhaskar, I said already, maximum bits. Why not S1 means you want to use only one bit is 1. No, I can use 2 bits for the next pattern. Maximum bits. Yes. That's what I've been saying, Arpitanand. Yes, only one, Ashutosh. Overlapping or non-overlapping. General things are, general assumptions is, you may be having that always pattern must be started with one only. No, not required. Not required. I can have a pattern like this, 0, 1, 1, 0. Draw state diagram for 0, 1, 1, 0. People think that only pattern must be started with one only. No. Param, overlapping means maximum bits should be used. Use only maximum bits, not two overlappings. Now, you may be having opinion that sequence must be started with one only. No, it can be started with 0 also. Draw state diagram for 0, 1, 1, 0. No, only one, Akash. Only one. Draw state diagram for 0, 1, 1, 0. 0, 1, 1, 0. Right? Yes, not. Getting a 0, moving to next state. Difference is there. So in S naught, if you are getting 1 is discarded now. From S naught, if you are getting a 1 is discarded. 1 is discarded. Ashish Kumar, just check it. So you might be new to this. Please go through that again and again. I'm there to help you. Don't get right. Right, correct, Manisha. Yes, you're right. So from S1, if you are getting a 0, what is it here? S1 means already we have a 0. Now we are getting another 0. 0, 0 is not required. 0, 0 is not required. Then discarding this 0, 0 is required. Then stay in the same state. Observe correctly. Don't do any mistakes. From S1, again, if you are getting 0, 0, 0 is not required. Right? Discarding 1, 0, I have to use 1, 0. From S1, if you are getting a 1, that means already we have a 0, you are getting another 1. 0, 1 is required. Then S2. Right? Correct? 0, 1. 0, 1. S2 is 0, 1. Now in 0, 1, if you are getting a 0, that means S2 state, if you are getting a 0, 0, 1, 0 is not expected. Then discarding this 1, 0 not required. Discarding this 0 is required. As 0 is required, it is going to S1. Someone was asking this one. Depending on situation, it may be going, but not compulsory. Right? See, from S2, means already we have a 0, 1. You are getting a 0. 0, 1, 0 is not required. Discarding 0, 1, 0 not required. Discarding 1, 0 is required. 0 is required means S1 state. Right? Next. From S1, what is it here? S1, 0, 1. Now, if you are getting a 1, 0, 1, 1 is required. Required means remember it. S3. What is it here? It is a what? 1 by 0. 1 by 0. If you are getting right, 1, it is required from S2. 0, 1 already there. You are getting 1, 0, 1, 1, S3 state. So if it is 0, 1, 1 already available, that is S3 state. Now from this, you may be getting 0, you may be getting 1. If you are getting 0, completing the pattern. completing the pattern, it is expected. Then moving to expected state by making output equals to 1. So which state is that? Depending on overlapping or non-overlapping. If it is overlapping, what is it here? 1, 1, 0 not required. 1, 0 not required. 0 is required. So it is going to S1. For overlapping, 0 by 1. 0 by 1. Correct? Now in this S3 state, 0, 1, 1, if you're getting a 1. What is it here? So I forgot to mention that what is it here? Overlapping. I need to write it is overlapping. No doubt it is 0 by 1. 0 by 1. So now in S3 state means we have 0, 1, 1. If you're getting 1, so 0, 1, 1, 1 is not required. Discarding this, not required. Nothing is required. Go back to S0. Go back to S0 for 1 by 0. If anyone has any questions, let me know. I will help you. That depends on pattern, Mangesh. Don't expect always it must be coming to S0. May not be. Mangesh, depending on situation, we have to take a decision. Every time it should not be coming to S0. In the previous case, it happened because of pattern. Not compulsory to get S0 always. Mangesh. Yes, that's what I have shown. It is overlapping. The red one is non-overlapping. 0 by 1. From S3 to S1 overlapping. What is that overlapping? Let us see. S3 means what? 0, 1, 1. If you are getting a 0. From this, what we need to learn? If it is overlapping, how many bits can be used? Discarding this 1, 1, 0, not required. Discarding this 1, 0, not required. Discarding this 0 is required. 0 is required means how many bits? Only 1 bit. 1 bit can be used for next pattern. So the state is what? S1. Please understand. How many bits I am using for next pattern? Only 1 bit. Only 1 bit. Ashtosh. Neeraj Meshram. Thank you. Right. Understood? Okay. Let me take a small break and 15 minutes break from now. We'll resume and we'll do designs. Then we go for another possible state diagrams. What is the other one also we discuss? Everything will be discussed. So let me take a small break. We'll resume after 15 minutes from now. Right, welcome back. After deciding number of states, after deciding number of states, if it is n, that n must be less than or equals to 2 power n. What is n here? Number of flip-flops we are deciding now. Minimum n value satisfies the equation is called minimum number of flip-flops. Right? What is n? Number of states. Number of states. What is here? Number of states. Capital N is number of states. Then we are deciding minimum number of flip-flops required to design the system. So let me take one example to understand this. Let me take 1101. Let us design the system. 1101. How many states we are using? 4 states. 4 states we have. So let us design the system for 1101 by writing state diagram quickly once again. What is here? 1101. S naught getting a 0, 0 by 0. S1 getting a 1. And again getting a 0 from here to here, 0 by 0. If we are getting a 1, S2. What is here? 1 by 0. If you're getting a 1 here again, 1 by 0. If you're getting a 0, S3 state. Let us implement one, either overlapping or non-overlapping. So let me say it is 0 by 0. If you're getting a 1, it is a 1 by 1. If you're getting a 0, 0 by 1. What is this overlapping? It is a overlapping. So then what should I do here is a simple thing is next step is what the state table, the state diagram for a given pattern or sequence detector. Now state table is present state, present input, next state and output. Let us write this. Present state, present input, next state and output. Present state S naught. In that the present input is 0. What is next state? Listen carefully. Present state is S naught. Present input is 0. Next state is what? S naught only. What is the output for this? 0. Present state, if you are getting a 1, what is next state? S1, output is 0. I hope everyone is following. From S naught, getting input is 1. Next state is S1, output is 0. From S1, present input is 0. Then what do we get here? 0. Next state is what? S naught, output is 0. S naught, output is 0. S1 getting 1. Help me. S1 getting 1. What is next state? S2. Output is 0. S2 getting 0. S2 getting 0. What is it? Next state is what? S3. Output is 0. S2 getting 1. Next state is S2. Output is 0. S3 getting 0. S3 getting 0. What is next state? S naught. Output is 0. S3 getting 1. Getting 1. What is this? It is S1. Output is 1. In overlapping. It is overlapping. So, as we observed, number of states is 4. What is the minimum number of flip-flops required to design the system? 2 flip-flops. With 4 states means 2 flip-flops is sufficient minimum. So, 2 flip-flops Q1, Q0 if I consider, it can be 0, 0, 0, 1, 1, 0, 1, 1. The states we are saying that S0, S1, S2, S3. But in reality, when we are using flip-flops, it can be states 0, 0, 0, 1, 1, 0, 1, 1. So now let me assign this. S0, S1, S2, S3. What I'm doing now? Assigning, state assignment, state diagram, state table, state assignment. Do I need to use same order? Not required. You wish. You can use your own order also. Your own order also. Right? That is writing state table, Then state assignments we have done. How we have done state assignments? As we discussed, number of flip-flops required is 2 because 4 states only. Then using the 2 flip-flops Q1, Q0, 0, 0 is S0, 0, 1 is S1, 1, 0 is S2, 1, 1 is S3, 1, 1 is S3. Once you are deciding this, what is next? Designing the system. Designing the system. Let us see what is it here. So present state, once again, present state, present input is X, next state is Q1. Sorry, let me see that. Next state. Present state is, present input is there, next state is there, and flip-flop inputs. Now I need to go with the flip-flops and output Z, output Z. So here, present state of Q1, Q0, present input is X, next state of Q1, Q0, flip-flop inputs is, if I use D flip-flops, D1, D0, output is Z if I use. Check it correctly. I'm assigning that states. After that, I'm trying to design the system. So I'm replacing S0 with 0, 0, S1 with 0, 1, S2 is 1, 0, S3 is 1, 1. So S0 means 0, 0, X is 0. 0, 0, X is 0. What is next state? S0 means 0, 0. For this state transition, what must be D1, D0? 0 to 0. It must be 0, 0 to 0. Again, 0. What is the output for that? 0. Again, S0, 0, 1. X is what? 1. And what is the next state? S1. What is S1 according to our assignment? 0, 1. What is the inputs we are expecting? D1, D0. 0, 1. Output is 0. So now S1, sorry, it is S0 only. So now if it is S1, 0, 1, if X is 0, input is 0. S0 next state is 0, 0. Inputs required is 0, 0. What is the output? 0. S1, 0, 1, S1, 0, 1, X is 1, X is 1. What is next state? S2, which is 1, 0. Inputs required is 1, 0, and output is 0. And S2 and X is 0. What is next state? S3 means 1, 1. Inputs required is 1, 1. Because D flip-flops we are using, it becomes very easy. Next state becomes a flip-flop inputs. Output is 0. S2 is 1, 0. S2 is 1, 0. Input is 1. What is next state? S2? 1, 0. Inputs required is 1, 0. Output is 0. S3? 1, 1. Input is 0. What is next state? S0? 0, 0. Then what is that? Inputs required? 0, 0. Output is 0. S3, X is 1. S3, X is 1. Then what is next state? S1 means 0, 1. Inputs required 0, 1. Output is 1. Output is 1. Now what should I do? Finding expression for D1, D0 and Z in terms of Q1, Q0, X. Once again, finding expression for D1, D0 and Z in terms of Q1, Q0, X. Q1, Q0, X. Then 0, 1, 2, 3, 4, 5, 6, 7. Let me write D1. D1 is equals to, help me, D1 is equals to sigma M of, what is here? 3, 4, 5. Am I right? 3, 4, 5. D0 is equals to what? Sigma M of. Sigma M of what is it here? 1, 4, 7. 1, 4, 7. And Z is equals to what? Sigma M of 7. Sigma M of 7. D1 equals sigma M of 3, 4, 5. D0 equals sigma M of 1, 4, 7. Z equals sigma M of 7. Once again, let me write these. D1 is equals to sigma M of 3, 4, 5. D0 is equals to sigma M of 1, 4, 7. Z is equals to sigma M of 7. Minimize this using K-maps. Using K-maps, if you minimize, not required, but let me do all these. For objective exams, you are not going to design 3, 4, 5. This is one grouping, this is another grouping. Then what we get here, D1 is equals to Q1 bar Q0 X plus Q1 Q0 bar. Q1 Q0 bar. And one more for D0. For D0. What we have here, Q1 Q0 X 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. 1, 4, 7. Then no possibility for minimization. D0 is equals to Q1 bar, Q naught bar X plus Q1, Q naught bar X bar plus Q1, Q naught X. What about Z? Sigma M of 7 is nothing but Q1, Q naught X. So finally, what is the conclusion is I am designing the system. D1, Q1, Q1 bar, D naught, Q naught, Q naught bar. So I'm not writing entire circuit. There is a combination of circuit. There is a combination of circuit. What is the inputs of this combinational? Q1, Q naught, X. And again here also Q1, Q naught, X. What about output Z? Q1, Q naught, and also X. That is Z. Q1, Q naught, X. This much is not required for our objective exams. So for ESC students, for conventional, once again, I'm going to discuss many examples on this FSM. So until that, please hold on. So at this moment, what we need to understand here is output Z is depending on state Q1, Q0, and also X input. Output is depending on state as well as input. This system is called Mealy FSM. So just to conclude this only, I have done this much. Otherwise, not required. We are not going to design the systems in objective exams. At the most, they may be asking number of states, number of flip-flops, and what can be the sequence it is detecting. This type of questions we have been getting. Or how many times the sequence is there for a given serial input data. These type of questions we have been getting in objective exams. So, but to confirm it is a Mealy system, a statement about Mealy FSM is nothing but output depends on state as well as inputs. That is called Mealy FSM and Mealy system. Output depends on state as well as input. Output depends on state as well as input. That system is called Mealy FSM. Mealy FSM. So second system is there, Murray systems. What is Murray systems? Output depends only on state. Output depends only on state. Then it is called Murray FSM or Murray systems. Once again, what we have discussed till now is Mealy FSM or Mealy systems. The next one is Murray FSM or Murray systems. We have Murray systems. Once again, so whatever we have analyzed till now is output Z is depending on state as well as input X. So it is called Mealy system. Let us see Murray systems. What is Murray systems? Output depends only on state. Output is not depending on input. Such systems are called Murray systems. Once again, Murray FSM or Murray system. Output depends only on state. Output is not depending on input. Such systems are called Murray FSM or Murray systems. Let us see what is that Murray FSM or Murray machine. What is that Murray FSM or Murray machine? Let us see. What is it here? Murray. Mealy systems or Mealy FSM. Output depends on state and input. Murray systems. Output depends only on state. Only on state. Output depends only on state. That is called, yeah, Bharat Chandra. Why I was that much fast is not a required thing. That's the only thing. Otherwise, I don't have any intention to speed up. Bharat. So here, simply from this, we have written this, then state assignment, then how to design the system. I have shown this already. You know how to minimize the expressions and how to draw the circuit. I may be a little bit speed in writing these, but is there any concept which we need to understand in writing? No. So output Z is depending on state as well as input. Just that is important thing from these. Bharat Chandra. I'm not speed up. I don't want to speed up. No worry. If required, I'll take 2 more days. Not a problem. Right? Don't worry. Right. So depending on requirement, I go with that. Right. So finally, what is it here? Whatever the systems we have designed are Mealy systems. Mealy systems. The other one is a Murray system. Other one is Murray system. So which we need to analyze is Murray systems. So far we have discussed our Mealy systems, in which if you are observing while writing state diagram also, we are writing state and input, then specifying output. So from the state, input and output is decided by state as well as input. So while writing output, what we are considering, which state, what is the input, then we are writing output. See, clearly while writing state diagrams itself, if you are observing a state and what input we are getting, then what is that output? So state as well as inputs are deciding the output. That is Mealy systems. Whatever systems so far we have discussed are Mealy systems. What about Murray systems? Output depends only on state. Output is not depending on input. Output depends only on state. Such systems are called Murray systems. Let us see how to draw state diagrams for Murray systems or Murray FSM. So once again, what is it here? So far, whatever we have analyzed, there itself you are observing state and what is the input from that state is deciding what is the output. State, input are combined deciding what is the output. But now what we are seeing here, output depends only on state. Output is not depending on input. Output is not depending on input. Let us draw FSM for such a system. So let me draw for 1, 0. Listen carefully. So on arrow, now onwards we specify only input. There won't be output. On arrow, we write only input. There won't be out because output is not associated with input. Output is associated with the state. Output is not associated with input. In earlier system, state as well as input, output is associated with input. But here, output is associated with state only. Now, for 1, 0, let me draw state diagram in Murray systems. So 1, 0. Same concept. Only thing is little bit different. Yes, not initial state. Nothing is found which is required. Nothing is found which is required. Now I need to specify output for this. Output is 0, right? Because nothing is found which is required. How can I give output is 1? Output is 0. Output is 0. Yes, not. Output is 0. Listen carefully. Yes, not output. Why we are saying output is 0? Nothing is found which is required till now. How can I say output is 1? Output is 0. Output is defined for a state now. Now, in this, you may be getting 0, you may be getting 1. If you are getting a 0, 0 is not required as the first bit. Stay in the same state. Significance of state we are confirming. What is significance of state now? So nothing is found which is required. Even though you are getting 0, 0 is not required as the first bit. Discarding that 0, staying in the same state. Staying in the same state. Right. Now, if you are getting a 1, if you are getting a 1, if you are getting a 1, what is it here? If you are getting a 1, if you are getting a 1, required to remember. How can it remember? By changing the state. S1 by S1 by, can we say output is 1? No, because we are getting only 1 bit. So output is 0. Output is 0 for logic 1 input. Observe correctly, try to understand correctly. From this initial state, if you are getting a 1, 1 should be remembered. How it can remember? By changing the state. Because S0 significance is nothing is found. But to say already we got a 1, we need to use a state, that is S1. For that output is what? 0. Because it is not found 1, 0. It is found only 1. So partially it is completed, not fully completed. So output is 0. Now from S1, you may be getting 0, you may be getting 1. If you are getting 1, what do you mean by S1? Already we have a 1. If you are getting another 1, 1, 1, is it required? No, discarding this. 1 is useful for the matter. So it is staying in the same state for logic 1. For logic 1. Listen carefully. S1 means already we have a 1. S1 means already we have a 1. Now you are getting another 1. Now you are getting another 1. Then staying in the same, because 1, 1 is not required. Discarding 1, 1 should be remembered. Yes, 1 is required, 1 is used. So that is the reason S1 state. So as we are getting another one, two ones is not required. I need only one. So I discard earlier one, holding the recent one, staying in the S1 state only. In S1 state means already we have a one. So other possibility is what? Getting a 0. 1, 0, 1, 0. Then completing the pattern. So in S1 state, if you are getting a 0, if you are getting a 0, yes, completing the pattern. Now you need to make output is 1. Where is the possibility for making output is 1? It cannot be specified with respect to input. So I need to use another state, important thing. So I need to use another state to say output is 1, to say output is 1. For input 0 from S1 state, completing the pattern 1, 0, you need to say output is 1. Output is 1. I can specify using another state only. It is possible. Otherwise, it is not possible. Otherwise, it is not possible. Right? Are you there? Yes. Not completed. It is not completed. From S2 again we need to analyze for 0 as well as 1. What is S2? 1, 0 is already observed. See clearly. This is important for Moore. For Moore system, this is important. Try to write here. 1, 0 already we have S2 state. Now you may be getting 0, you may be getting 1. You may be getting 0, you may be getting 1. So if you are getting a 0, appending a 0, listen carefully. Appending a 0, then discarding this, not required. Discarding this, not required. Discarding this, not required. So go back to S0 for logic 0. From S2 means what do you mean by S2? Already we have a 1, 0. Now you are getting a 0. From S2 also, again we need to analyze for 0 as well as 1. From S2, that means already we have a 1, 0. Now you are getting a 0. So if I discard this, not required. Discard this, not required. Nothing is useful. Then go back to S1. Now in S2 state, you may be getting 1. What do you mean by S2? Already we have a 1, 0. You are getting a 1. You are getting a 1. Then discarding this 0, 1. Discarding this 1. 1 is useful for next pattern. So go to S1. Don't take it S0 by default. Check it correctly. Check it correctly. So S2 means 1, 0. Now you are getting 1. So then what we do? Discarding earlier one, 0, 1 is not required. Discarding this 0, 1 is required. 1 is required. Which state is that? S1 state. Be clear about this. There is a possibility for doing mistake because one state extra we are using compared to melee to specify output is 1. To specify output is 1. We are using one state is extra. One state is extra. Right. So from S1, if you are getting a 0, that is 1, 0 is completed. To say output is 1, we need to use one extra state. We need to use one extra state. Chakrabarti, what is your doubt? What is your doubt? S1 to S0. Where? In which one? S1 to S0? Please, Chakrabarti. Right? Now, try 110 pattern to understand more. Again, write Moore FSM for 110 pattern. Moore FSM 110 pattern. 110 pattern. Okay. For 110 pattern, if I write a FSM state diagram in Moore FSM. So S0, first initial, output is 0. Initial. So for 110 pattern, first bit if it is 0, 0 is not required. Discarding that, stay in the S0 only. If you are getting a 1, if you are getting a 1, if you are getting a 1, then required to remember changing the state S1 by 0. S1 by 0 for logic 1. For logic 1. Right? S1 by 0. So in S1 state, again, you may be getting 0, you may be getting, if you are getting 0, 1, 0. 1, 0, right? 1, 0 is not required. Then discarding 1, 0 is not required. Discarding this. What is it here? Go back to S0 for logic 0. For logic 0. In S1, you may be getting, in S1, you may be getting 1 also. If you're getting 1, in S1 is already we have a 1, we are getting 1. 1, 1 is required, bro. Required to remember. S2 by 0. It is not completing the pattern, so it is 0. Sorry, it is 1, right? It is 1. So 1, 1 is required. So it is moving to next state to remember. Now in S2 state, because S1 0 possibility completed, 1 possibility completed. Now S2 state. What is S2? Already we have 1, 1. Already we have 1, 1. If you are having a 0 or if you are getting a 0, it is required. 1, 1, 0 is completing the pattern. So S3 by 1 because completing pattern for logic 0. For logic 0. In S2 state means already we have a 1, 1. If you are getting a 1, triple 1 is not required. Discarding this 1, 1. So 1, 1 is required to remember. Which state is that? S2 state only. So S2 means already we have a 1, 1. You are getting another one. Triple 1 is not required. Discarding this 1, 1 is required. So it is staying in S2 state. It is staying in S2 state. Yes. From S2, 0 possibility, 1 possibility complete. Now in S3 state, what is it here? 1, 1, 0 already we have. Let us complete remaining also. In S3 state, means already we have 1, 1, 0. Now you may be getting 0, you may be getting 1. If you are getting 0, discarding this 1, 0, 0 not required. Discarding this 0, 0 not required. Discarding this is not required. So go back to S0. What is it here? For logic 0. From S3 means already we have 1, 1, 0. 1, 1, 0 already we have. Now if you are getting 1, then what should I do? Discarding this 1, 0 not required. So discarding this. Discard. 1 is required. So it is going to S1. It is going to S1 for logic 1. For logic 1. Check it correctly. Last one, bit dangerous here. Don't take a chance. Here, appending bits, we need to take a decision. So, for appending bits, so is it possible or not? We are observing. So, even though it is 1, even though it is non-overlapping, what is it here? It is not going to S0 because coming bit should be utilized. So, here we are completely specifying 1, 1, 0, a separate state. From that, again, you may be getting 0, you may be getting 1. So now, next thing you may be understanding more when you are observing overlapping and non-overlapping. So when we are getting into overlapping and non-overlapping, you may understand more. Just wait. Just wait. Because you don't have overlapping and non-overlapping in this. Now, let us see what is that overlapping, non-overlapping also in Murray systems. Is that clear? Writing state diagram. Writing state diagram. So for 1101, for 1101, for 1101. What is that, Manisha? I did not understand. I'll talk to you later. Please wait. Please wait. I will talk to you. What is that possibility? I'm not understanding. Just wait. Let me complete this. I want to introduce that concept also. Right. 1101. Yes, not. Listen carefully. Yes, not. Output is 0. Initial. If you are getting a 0, 0 is not required as first bit. Same state. If you are getting a 1, required to be remembered. S1 by 0. If you are getting a 1. Right? If you are getting a 1. Now from S1, if you are getting a 0, what is it here? After getting 1, getting 0. 1, 0 is not required. Discarding 1, 0 is not required. Discarding everything. Go back to S0 for logic 0. If you are getting a 1, if you are getting a 1, then what is it here? S1 already we have a 1, we are getting another 1. 1, 1 is required. So S2 by 0 for logic 1 from S1 state, right? S2 state. What is S2 state? already we have a 1, 1. So now you may be getting 0, you may be getting 1. Listen carefully. Please wait. Please wait. You will understand. Right? Try to understand correctly. Yes, sir. What is it here? So what is the S2 state? We are getting 1, 1. We are getting 1, 1. So already we have a 1, 1. Now you may be getting 0, you may be getting 1. So what is it here? Already we have a 1, 1. Now you may be getting 0, you may be getting 1. If you're getting a 0, 1, 1, 0. Is it required or not required? Required. Required to be remembered. Then S3 by 0. For logic G. What is S2 significance? Already we have 1, 1. You are getting a 0. 1, 1, 0 is required. Yes. Now, in S2 state, you may be getting 1 also. What is S2 state? Already we have 1, 1. You are getting another 1. Triple 1 is not required. Then discarding this 1, 1 required. So it is staying in same state for logic 1. For logic 1. Check it correctly. Right? Now, from S2, 0 possibility, 1 possibility completed. Now S3 state. What is S3 state? 1, 1, 0. S3 means already we have 1, 1, 0. Now you may be getting 0, you may be getting 1. If you are getting 0, 1, 1, 0, 0. S3 means 1, 1, 0. Now you are getting a 0. 1, 1, 0, 0. Is it required? Not required. Then discarding earlier, not required. Discarding this, not required. Discarding this, not required. Discarding. So go back to yes, not. For logic 0. From S3 state, if you are getting a 0, 1, 1, 0, 0 is not required. And if you are observing, none of the bits are useful for the pattern also. Then discarding everything, going back to S naught. So in S3 state, if you are getting 1, what is S3? 1, 1, 0. If you are getting a 1, 1, 1, 0, 1, completing the pattern. Then what will I do? S4 by 1. Because completing the pattern. For logic 1. S4 is the state to say output is 1 because completing the pattern 1, 1, 0, 1, 1, 1, 0, 1, 1, 1, 0, 1. Right? Now, from S4, you need to decide. What is S4? Already we have 1, 1, 0, 1. Listen carefully. Already we have 1, 1, 0, 1. From this S4, you may be getting 0, you may be getting 1. If you're getting a 0, let us see. Discarding this, not required. Discarding this, not required. Nothing is required. Go back to yes. For logic 0. Now, very good. Now, if you're getting a 1 from S4 means 1, 1, 0, 1. If you're getting a 1, if you are getting a 1, let us see what happens. What is here? Let us see. Now, is it overlapping or non-overlapping should be decided. Listen carefully. Right? Overlapping or non-overlapping. If it is overlapping, what should I do? If it is non-overlapping, what should I do? If it is non-overlapping, then what should I do? Where it has to move? If it is non-overlapping, where it has to move? If it is non-overlapping, where it has to move? If it is non-overlapping, where it has to move? If it is non-overlapping, where it has to move? Yes. Yes. Very good. Some of you are answering correctly. Some of you are doing mistake, which I am expecting. Very good. Yes. People are saying, what is it? S not for non-overlapping becomes wrong here because I cannot discard all the bits. I can discard only the pattern. I can discard only the pattern. Listen carefully. I can discard only the pattern. Now, this one is useful. I cannot discard all the bits. Earlier, all the bits, but here, only pattern. There, including bit, it was pattern. Now, coming bit is not from the pattern. Already, pattern is completed in S4 state itself. The pattern should be discarded. Coming one should be utilized. Then, If it is non-overlapping, going to S1. Check it correctly. For logic 1 from S4 state, if it is non-overlapping, discarding only pattern 1101, coming one, the bit should be used, that is a S1 state. If it is overlapping, listen carefully. If it is overlapping 1101 S4 state, you are getting a 1. Then discarding this 1011 not required. Discarding 1011 not. Discarding this 11 is required. As 11 is required, which state is that? S2 state. For overlapping, it is S2 state. See clearly. Let me mention here. It is overlapping. And this is a non-overlapping. Overlapping and non-overlapping. See, be clear about the concepts correctly. Don't take any decisions with assumptions. Put on a paper, then write. Then you will understand more. Right? So, if it is overlapping, so discarding from first bit. If it is non-overlapping, discarding only pattern. Point is very clear. If it is overlapping, discard from first bit, earlier bits. If it is non-overlapping, discard only pattern. Right? May be required sometimes, Ujjwal. Depending on applications, it may be required. Right? It may be required in some applications. Right? So, okay. Please complete 111. Draw Moore FSM for 111. Yes, Chakrabarti. Final. That is non-overlapping means going to S, not in Mealy, not in Moore. Very good. Non-overlapping goes to S1. Overlapping goes to Dinesh sir, correct. Overlapping goes to, doing a mistake. Overlapping goes to S3 itself. Very good, Manisha. Yes, yes, it is S3 itself. Overlapping goes to S3 itself. Very good. Most of you are doing correctly. S naught by 0, initial. Getting a 0, same state. Getting a 1, remembering by changing the state. Now, if you are getting a 0 from S1, not required. 1, 0 is not useful, right? Discarding this. Go back to S0 for logic. In S1, if you are getting 1, required to remember. 1, 1, required to remember. What is it here? S2 by 0 for logic 1. For logic 1. In S2, what is it? S2 already we have 1, 1. In this, you may be getting 0, you may be getting. If you are getting a 0, 1, 1, 0 is not required. Nothing is required. Go back to S0 for logic 0. If you are getting a 1 from S2, S2 means already we have 1, 1, we are getting another one. Triple 1 is required and completing the pattern. S3 by 1. What is this here? Logic 1. So from S3 means already we have triple 1. Already we have triple 1. Now you may be getting 0, you may be getting 1. If you are getting a 0, no problem. It is going to S0 0. If you are getting a 1, what is it here? S3 1 1 1. If you are getting a 1. If it is overlapping, what should I do? Discard only this bit. Then triple 1 again. Then what is the state? If it is non-overlapping, what is it here? S3 is 1 1 1. We are getting 1. If it is non-overlapping, discarding only pattern, getting 1. Which state is that? Going to S1 for non-overlapping. For non-overlapping. For non-overlapping. Very good. Very good. Most of you are doing correctly. Excellent. Superb. All of you are doing correctly. Now, let me design one system, Moore system also to understand. What is it? What is the Moore system, sir? Let us understand that. Right? So, let me take a simple, what we have discussed, 110 pattern. Let me design that. S0 by a 0 and input is 0, same state. Input is 1, S1 by 0. You are getting 1 from S1. If you are getting a 0, again back to S0. If you are getting a 1, again S2 by 0. You are getting a 1. So if you are getting a 0, again S3 by 1 for 0. If you are getting a 1, again it is same state. If you are getting a 0 here, it is going to S0. If you are getting a 1, it is going to S1. Right? This is 110 pattern. 110 pattern. Same.